This is GCT Tutors. Today I'll be solving question on circle theorem. I hope this video will help you at the end. Please remember to like this video, subscribe, and also turn on your notification button for any of my subsequent videos. Without much ado, let us start. Okay, we have question 1a. P, Q, R, and L lie on a circle center O. Angle OPS equals 42 degrees OPS. And angle PRQ equals 35 degrees. Calculate Roman figure 1 angle POS. Alright, before I solve this, I would like us to consider the theorems that I will be using to solve this very particular question. So I have it at the down on page 2. Okay, you can see I have important circle theorems for the above question. Okay, the first theorem that we're going to look at is called the angle which, this is the first one that we're going to look at. The first one we're going to look at. And it says that the angle which an arc of a circle subtends at the center is twice the angle the same arc subtends at the circumference. Now, AB is the arc, is an arc of this circle. Now we are told that the angle that this arc AB subtends at the center, we can see it, and that angle, which is this AOB, we can see it, angle AOB, is twice, means 2 times the angle that same arc is subtended at the circumference, which is ACB. So angle O here is twice angle C. That is what that is telling us. So if, let's say for instance, if the angle here is 12 degrees, automatically this will be 24 degrees. And if you are given only the center, you just divide to get the angle at the circumference. So the first one is the angle which an arc of a circle subtends at the center is twice the angle that same arc subtends at the circumference. That's the first one. Please note that. All right. And the second theorem that I'll be making use is called the opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. Now, a quadrilateral is a polygon with 4 sides. You can see this quadrilateral AYBX. You can see it. It has 4 sides. This is side 1, 2, 3, and 4. That is why it's called a quadrilateral. But it is a special quadrilateral. We call it cyclic because why? If you look at the 4 corners, which are called the vertices of these quadrilateral, all the 4 corners are touching the circumference. This is our circumference. This is the circumference. The corners, all the vertices A, Y, B, and X are all touching the circumference of that circle. That is why we call this quadrilateral a cyclic quadrilateral. And the rule is that the opposite angle of a cyclic quadrilateral, you can see X and Y, they are directly facing each other, they are opposite. So X plus Y equals 180 degrees. And also we can see that A and B, they are also opposite. So A plus B equals 180 degrees. So note, the opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. And the last theorem that I will be making use in this question: angles in the same segment of a circle are equal. Now, we know what is a segment. A segment is a region bounded by an arc and a chord. If you look at AE, this AE is a chord, and I also have this, this line AE is a chord, and I have this called an arc. This is an arc. The region bounded by an arc of a circle and a chord is called a segment. It's called a segment. And this segment is known to be a minor segment. Why? Because we also have these other parts of the segment called the major segment. So the rule is angles in the same segment of a circle are equal. If I look at angle ABE, that is this angle here, is found on this segment, and also angles ACE is also found on that same segment, and lastly angle ADE is also seated on that segment. Okay, because they are seated on that same segment, so they are the same. So x equals x equals x. So having said this, I think we can now go straight to the question so that we can solve it together. All right, so let me go back to the main question now. So now that the theorem is clear to us, so we can start with the solution now. So the first question, we are to find angle POS. Angle POX. So this is the angle we are looking for in red. Angle POS. Now, it's not that hard. Now, we know that line PO is a radius. Yes, a radius is a line drawn from the center of a circle that touches any part of the circumference. That's the radius. Also, OS, you can see it, it's also another radius. Okay, so now we have two radii. Now, if you look closely, we have formed what we call isosceles triangle. This is this side equals this side. This length PO must equals to OS. The radius is equidistant from any part of the circle, Okay, so and we know that base angle of isosceles triangles are equal. So this is the base angle. So if this is 42 degrees, this angle here also must be 42 degrees. Why? Base angles of isosceles triangles are equal. Then I can get my POX, angle POS, considering this triangle. We know that the sum of angles in a triangle equals 180 degrees. So I can get my angle POS. So we have POS, angle POS plus the two angles of the isosceles triangle must equal to 180 degrees. Okay, we add this angle here, and this angle here, equating them to 180 degrees. Then we have angle POX plus 42 plus 42 will give us 84 degrees equals 180 degrees. Therefore, angle POX equals 180 degrees minus 84 degrees. And if you do that, that will give you 96 degrees. Okay, if you subtract that, it will give us 96 degrees. If you subtract 84 from 180 degrees. So angle POS is 96 degrees. I think that is clear. All right, we move on to the next question. The next question, we are to calculate angle PRS. Angle PRS. Okay, let me say it again. We want to calculate angle Okay, we want to calculate angle PRX. Okay, PRS. This is the angle we are looking for. Angle PRX. Okay, remember in one of the theorems that I showed us before this solution, which is I said that angles that an arc of a circle subtends at the center is twice that same arc subtends at the circumference. You can see this arc, okay, sorry for that, this arc PX subtends angle POS at the center here, okay, and we say that that same angle is twice the angle that same arc subtends at the circumference. This is the circumference. So we just calculated this to be 96 degrees. So if the angle at the center, which is POS, is two times the angle at the circumference here is angle PRS. So I'm looking for PRS, and I know my angle POS to be 96 degrees. Okay, we can see that. So dividing both sides by 2, we have that. So therefore angle PRX must equals to 96 divided by 2. If we divide 96 divided by 2, that will give us 48 degrees. So this angle here equals 48 degrees. Okay, I think we're getting it. This is 48 degrees. And the next one is angle SPQ. Angle SPQ. Okay, let's look at our diagram closely also. We are looking for angle SPQ. Look at it, SPQ. So the whole of this angle here, that's what we are looking for. Now, initially I told us that this quadrilateral is a cyclic quadrilateral, and the opposite angles of a cyclic quadrilateral are supplement, they add up to 180 degrees. So it means that if I add 35 degrees this angle here, plus 48 degrees, plus 42 degrees, plus this other part of this angle here, everything must add up to 180 degrees. So what I'm going to do, since I'm looking for angle SPQ, the whole of this angle, so I want to find this smaller part here first. This smaller part here, let's call it gamma. Let's call it gamma. So we can say that angle gamma will be 180 degrees minus this angle here, 42 degrees, plus these other two opposite angles, 35 degrees plus 48 degrees. I think that's clear. It is gamma that I'm finding now, not SPQ. So gamma will be, now if you add 42 plus 35 plus 48 and subtract from 180 degrees, so we have 180 degrees minus this equals 125 degrees, and if you subtract that, we have gamma to equals 55 degrees. So this angle here, this small angle here, is 55 degrees. So since we know that, we can now find angle SPQ. We know SPQ will be 42 degrees plus that 55 degrees. So it's going to be 42 degrees plus 55 degrees. Sorry for that. 42 degrees plus 55 degrees. And when we add that together, I think that's 97 degrees. So our angle SPQ equals 55 degrees plus 42 degrees, which is 97 degrees. So this angle here is 97 degrees. And we have the question 4. We have to find angle PSQ. Angle PSQ. Let us go back to our diagram. You can see we are always referring to our diagram. Angle PSQ. Okay. PSQ. Okay. I want to use another color so that we can see very well. This is the angle we are looking for. This shaded part. Only this shaded part here. That is the angle we are looking for. This angle here. Angle PSQ. Now, if you look at angle QRP and also angle QSP, you'll see that they are in the same segment. Angle QRP, this angle here, and also angle QSP. Okay, you can see that which is the same angle PSQ. They are on the same segment. So if this angle here is 35 degrees, automatically this angle here must be 35 degrees. Why? They are seated on the same segment. So angle QRP must equals to angle PSQ. Angles on the same segment. So obviously the answer to this place is 35 degrees. I will have given the reason, but because of space, so the reason is angle in the same segment are what? Equal. Okay, the last but not the least. Okay, even though this is not part of circle theorem, but let us see and try to solve it. The interior angle of a regular polygon is 8 times as large as the exterior angle. Calculate the number of sides of the polygon. I don't know how many sides has that particular polygon, but I can do a rough sketch. Let us assume that the polygon looks like this. It has n side, I don't know. Okay, this side here will be my interior angle I. And if I extend this outward like this angle here will be my exterior angle E. Okay. Okay. Remember that. Very simple. I don't know the number of sides, so I am assuming that the polygon has n sides, and this angle here, this shaded part here, is the interior angle, while this unshaded part outside is called the exterior angle. Okay, we are also told that the interior angle of that particular regular polygon is 8 times as the exterior angle. So I will say let x be the exterior angle. So if x is the exterior angle, so the interior angle, this one is x, the interior angle is 8 times as large, so it means that the interior angle must be what? 8x. So 8x equals the interior angle. I think that's clear. That's the first thing. And the second thing, we know from our knowledge of geometry that sum of angle on a straight line equals 180 degrees. They add up to 180 degrees. So you can see that the interior angle here, which is 8x, and the exterior angle, which is x, they are on a straight line. So they must add up to 180 degrees. So I can say that 8x plus x equals 180 degrees. 9x equals to 180 degrees. So from here, we can get our x divided both sides by 9. So we have x equals 180 degrees divided by 9. And if we do that, we have 20 degrees. So that's not the final answer. What we are looking for is the number of sides. But there is a relationship between the number of sides and the exterior angle of any regular polygon. we know that each exterior angle of a polygon equals 360 degrees divided by n, where n is the number of sides. So if I make n the sort of formula, I have n equals 360 degrees divided by each exterior angle. And we have calculated the exterior angle, which is x, to be 20 degrees. So if I divide 360 divided by 20, I have 18. So the answer is 18 sides. So that very particular polygon has 18 sides. I think with that, we have come to the end of this tutorial video. I hope that this really helped. Please remember to like this video, subscribe, and also turn on your notification button. You can also share it with your loved ones. Thank you for watching. God bless you. Bye bye.